So we want to come up with a complete balanced equation. So the first thing we need to do is take the words and put them into chemical formulas so we can see what's going on here. So the first thing I'm going to look at, I'll use red, is the 2. That was terrible. the 2. Do it again. Again, that's a little better. It was still not great. The 2 formulas. So that's nomenclature, which is a separate topic if we want to go over that separate on a different question. But what we'll do is we find lead. Lead is Pb. And lead 2 means that it's lead 2 plus. Not that there's 2 leads. Nitrate I have to look up. Someone have that? What's the NO3? It's a polyatomic. And I need to know its charge. -1. So if I have a lead that's 2 plus and an NO3 that's only 1 minus, that's not going to balance out to a neutral compound. What would the final formula be? How many of leads do I need, or how many NO3s do I need? I need 2 NO3s because 1 minus and 1 minus makes 2 minus, and that balances 2 plus. So when I change all of this, I don't know how to erase it all very quickly, so we'll do this. It doesn't appear to erase anything. That does. When I rewrite that, instead of writing it like that, all I'm going to do is write Pb. Because I have 2 NO3s, I need to write NO3 2. That reacts with sodium chloride. Because it's IDE at the ending of chloride and not ATE, I know that that isn't polyatomic. It's just, whoops, it's very sensitive. Sodium with chlorine. Sodium is group 1, so it's 1 plus. Chlorine is group 17, so it has 7 electrons and needs 1 more for 8, which means it's 1 minus. Or you can just look right on your periodic table and it tells you 1 plus and 1 minus, so they're balanced. So that's the first step. This is going to react together. Those are the reactants to form. Now in yours, you guys would have it here, but of course I would run out of space, so I'm just putting the arrow lower. It would form something. So I have to know what type of reaction this is in order to predict how it's going to react. Given that I have, let's use color again, 1, 2, 3, 4. 4 different things. What's going to happen when something that's AB reacts with something that's CD? What type of reaction is that? Do-si-do, we call that what type of reaction? Double displacement. So 2 ways to do double displacement. You could say that metal switches with not the other metal, or we could do do-si-do, that the outside goes with outside, so Pb with Cl, inside goes with inside, but we always write metal first. Either way you come up with it, we get Pb going with Cl. That's a little far away. And sodium going with nitrate. That's the basic. That's not necessarily what the formula is, but that's what we're going to come up with. Now we got to figure out what the actual charges are. Lead was 2 plus, so it's still 2 plus. Chlorine, we remember, is 1 minus. So does that balance out, or do I need to add more of one thing? Which one do I need to add? Chlorine. I need another chlorine, so this is 2 chlorines, so that my charges balance out, and then I erase my charges because you don't keep those, remember, in there. It's fine to write them, but your final answer needs to be the proper answer. So PbCl2. And how about Na? Na was 1 plus, NO3 was 1 minus. That works out fine. So we've done step 1. We had to, well, step 3 actually. Step 1 was write down what we start with in the formula. Then we figure out what type of reaction so we can predict a product. We did that. We wrote down the proper formulas. So this isn't a complete balanced chemical equation. We're missing 2 things. What are we missing? 2 things out of complete balanced chemical equation. The states, we need to predict, are they soluble or not, because if they're all soluble, then this reaction doesn't happen because you can't tell the difference between before and after. So if I can't tell the difference between before and after, I don't know if anything happened at all. The other thing would be, if it's a balanced chemical equation, What's missing for a balanced chemical equation? Nobody knows? Page? These are whatever. We have to make sure they're balanced. So let's do states first. So there's two ways to do this. I'm going to give you a little trick. I did that wrong. Solution and solution. If they are solutions, if it tells you in the question they're solutions, what does that mean? They are soluble or they're not soluble? They have to be. That's right, Mac. They have to be soluble because it says. We can double check just for practice. So I look up NO3 compounds. What's the rule for NO3 compounds on my chart? AQ, except. Are there any exceptions? No, they're all soluble. So this one is definitely going to be soluble, which is good because it says that in my question. In ACl, there's two different rules you can look at to tell you it's soluble. The chlorine compounds are soluble with just a couple exceptions. Or we look at group 1 compounds where sodium's from. They're all soluble. So either way, this is soluble. Let's look at PbCl2. Let's look up the chlorine. We always look up the anion. The rule for chlorine, soluble. Except, is Pb2 plus one of our exceptions? Yeah, lead-2 is an exception. So if the rule is soluble but it's an exception, that means it's not soluble, so it would be solid. That is solid. And we looked up nitrates were soluble, and we looked up sodiums were soluble. So sodiums and nitrates together are really soluble. Doesn't really matter how soluble, it is soluble. There you go. So you're almost done. Almost done. We figured out the states. We figured out what type of reaction. We figured out what the formula was. Now we just need to make sure it balances. I'm going to change the color here. Let's balance in blue. I've got lead. Since nitrate is the same here and here, I can balance the whole group together. Sodium and chlorine. This is the reactant side. This is the product side. Reactant side, there's one. There are two nitrates. There's one sodium and one chlorine. On this side, there is one, two Cl's, one Na, one NO3. Well, I think it's pretty apparent that it's not balanced. I have two NO3s that come from this PbNO3 which means how many NaNO3s do I have to make on the other side? Two at this point at least. So that means that there are two of those, but that also means that we have two NAs. I'll just go down to Na. Na only has one on this side, but two came out, so I need to have two over here. And I have two NAs go in, but I also have a Cl in this compound, so that makes that a 2. 1, 1, 2, 2, 2, 2, 2, 2. We have balance. So our complete balanced chemical equation is 1 lead-2 nitrate reacts with 2 sodium chlorides to produce 1 lead-2 chloride and 2 sodium nitrates. Just for the heck of it, since we already did this, we called this a double displacement. Didn't ask for that in the question, but we had to figure that out anyway just to figure out what the products were, so we might as well write it down because we did that. This has demonstrated basically every single thing that you're doing on your test in this one question. So if we can do this, you guys are doing pretty well. I think that's it. The only thing I will point out, if you don't have a solid somewhere, then that's what we say is no reaction. So if that was aqueous, that means when I mix two things together and it's still in solution, I can't see anything happening. It means that nothing did happen. It looks the same before as it does after, and we would say that that would be no reaction. Okay, so that's what we're going to look for in D.